Hello and welcome back to Calculus 1. It's finally back after this long and exhausting weekend, right? 3 days, no calculus. Luckily you had those quizzes and homework and stuff to work with, the labs, project. So now we can finally continue Chapter 5 exploration. These next two sections are somewhat short. We are talking about definite integrals and then the fundamental theorem of calculus after that. Tomorrow is going to be a big day because it's exam. Exam is tomorrow. We'll do one more short section after the exam, and then Wednesday we have all day for one section and the review. So definite integral. Definite integral is supposed to find the exact area under the curve under certain conditions, and we'll see what that is. Now, we said that the definition for the definite integral is given by the Riemann sum and goes to infinity. So we have n goes to infinity, I goes from 1 to n of f of ci delta x. And you can find the integral using the Riemann sum, or you can find the integral using the integral, the antiderivative. So say that you have a triangle like this. So you count, this is 3 and this is 6. And you want to know the area of this triangle. Sure, you can use the area of the triangle formula, which would be half of base times height, and the answer is 9. But why simple if we can do calculus, right? We can also set up this integral by first figuring out that the equation of this line is y equals, and we know it's rise over run, so it has to be negative 1/2, right? Because it's negative 3 over 6. So negative 1/2 x plus 3. That will be our equation here, the function. So now the area is going to be integral from 0 to 6, and then you have negative 1/2 x plus 3, everything in parentheses, dx. Now remember how I told you in 4.9, make sure you have the parentheses if you have addition and subtraction, because there is multiplication in front of dx. You see there is a multiplication in over here in your definition. You see that it's f times delta x, and we know that delta x and dx are the same thing. So there is multiplication here, which we don't write, and that's why we need these parentheses, because this dx needs to multiply both terms, negative 1/2 x and 3. So we put those parentheses. Another good thing that you should learn right away is to draw the representative rectangle. See, this is a representative rectangle I like to shade. And this representative rectangle has the width of dx, which is delta x. And the height, you can see that it's stretching between y equals 0 and the y equal a function. So that's why you have a function here. It's actually f of x minus 0 there, but we just write the function. So this representative rectangle here is called, this rectangle is called representative rectangle. And the width of that rectangle is delta x, and the height is the function. This is a rectangle. So you can see that over here you have the height times the width, and you know that length times width is area of the rectangle. So now that you have this, you will proceed to solve the problem using the antiderivative. So negative 1/2 and then x squared over 2 plus 3x. And now you write this vertical line computed from 0 to 6. So the vertical line computed between 0 and 6. I hate when it disappears. So now what we have is negative x squared over 4 plus 3x from 0 to 6. That's negative 36 divided by 6, negative 9, plus 18. Well, I didn't tell you how to compute this, but minus 0 plus 0, and all together is 9. Maybe I should go into next line. 19 plus 18 minus 0 plus 0 is 9. There we go. I erased this. So this is how you compute the area using integrals. You use the definite integrals, which has these limits, and the limits can be computed. So now let's write the formula that computes this. And this is major. So integral a to b of f of x dx is computed by figuring out first any antiderivative and compute that from a to b, which is f of b minus f of a. Guys, this is a major formula. You will be using this for as long as you take math classes. So you must know this. So let's compute antiderivative, the definite integral from 2 to 7 of 1 over x dx. What do we get? ln x computed from 2 to 7. Good. And what do we get there? Anyone? ln 7 minus ln 2. And if you know rules of logs, you might write that as a 1. I don't care about decimals. You don't have to bother. What is the area under the curve from 0 to pi for sine x dx? Go. What's the integral of sine? Negative cosine. Very good. And then we have 0 to pi. So we have negative cosine of pi minus negative cosine of 0. Which is negative 1. Negative 1. Cosine of pi is negative 1. So negative 1 plus 1, altogether 2. The next one, 3x squared plus 2x minus 1, computed from 1 to 10 dx. So how much is the integral of 3x squared? X cubed, good. And how much is the integral of 2x? Okay. So all of this computed from 1 to 10. We have 1000 plus 100 minus 10 minus 1 minus 1 plus 1. These guys cancel, and we have 89, right? So I would like to pick up 2 more problems from homework. Yes? Very good question. Why don't we put plus c? If I I'm going to answer that question by working out one problem here with, let's say, from 0 to 3 and just x dx. When I integrate x, I will get x squared over 2 plus c computed from 0 to 3. If I put plus c, look what happens. When I plug in 3, I get 9 over 2 plus c, minus, when I plug in 0, I get 0 squared over 2 minus another plus c. And then when this minus distributes, they cancel. They will cancel every single time. So we never put plus c for definite integrals. We must put plus c for improper integrals. So the answer is 9/2. The next problem is definite integral 0 to ln 5 of e to the x dx. What is the integral of e to the x? Good. Computed from 0 to ln 5. So we have e to the ln 5 minus e to the 0. How much is e to the ln 5? And how much is e to the 0? The answer is 4. Next problem is integral 0 to 8 of 3x times 4 minus x dx. What do we have to do first? Multiply it out. Good. All right. Just remember I have to do something. I'll be right back.
No one else should. I was literally like, you sent pictures, and like, the only one who was kind of like, yeah. She's never said it. Some guy called Danny. Danny has like one toe in the water. I mean, like, I know Danny did it. Like, I saw her last. Like, she has. So like, she's all those too. Yeah, she has all of them. Yeah. So I'm like. You always call Brian and be like, hey, what are you doing? And he's like, I work for like 7 hours. He said he'll send them tonight. And I am at 9 p.m. I'll text that motherfucker and be like, where are them loaves at? Danny said like in 10 minutes she'll be home, so she'll send them. So they used us for the first one. This is the second one. We can just look quick, so it's fine. Yeah, so I'm finished lab 4. And she has all of them. Yeah, I have like, we have like top 4 notes. So I'm gonna like try and study for the exam today by doing homework. Yeah, that's nice. Homework that I didn't study before. When I study by myself, I spend a good hour studying. When I study with friends, I usually don't figure out. That's not a problem. But you know, my top teacher, for driving to school personally. You could drive there and be like, since I'm here, do my laps. Since I'm here. Would he be there? Because I took a counseling course last year. It was intro. Like I finished breakdown, so it was like the concept. No. You're getting a credit for it? You just did it? My dad was a math professor. Yeah. And literally, ever since the 6th grade, there has not been a summer where I haven't been in my class. I know that summer. Not the whole summer, though. So there's good fun. Sorry, set. Are you doing some session? Yes. What's the they don't, they do different things. For like my major, I have to take X5s. Yep. Read a writing class, and then I'm doing a scientific writing class. Like it's like how to write the paper. Like every home. But yeah, it's like different for like every major, like your school year and when it's records. Like I'm in civil science. I can finish that's all that's I don't know. Like my friend was like, this is good. She said, I hate to get by 7.
Unless you're doing like specific problems.
I don't know. I'm a little afraid of the slip inside, especially doing it. Yeah, my friend Amanda was like, where we bought like the kids together. She's like, we're the one that kind of looks like mine whole match. And I was like, you want me to go to slip inside of that?
I guess you guys are done. So you said already the first deal is to multiply. So 12x minus 3x squared, right? dx. So what is the integral of 12x? And what's the integral of negative 3x squared? Compute it from 0 to 8. Plug in 8, that's 6 times 8 squared minus 8 cubed. And then when you plug in 0, all of it goes away. And you want to learn some of the computing skills? Look at this. You have 6 times 8 squared and 8 times 8 squared. So this is actually 6 minus 8 times 8 squared, which is negative 2 times 64, which is negative 128. What happened?
Nothing. Just so smart. Oh, I see. Yeah.
Yeah, use algebra instead of, I used algebra to compute it, not computation, not arithmetic. I factored out 8 squared. That's what I did. I factored out 8 squared, and what's left is 6 minus 8. It's much easier to double. Anyway, we'll do the next one. What's the next one? We cancel, right? We divide. So we get 1 over 6x plus 1 over 3 minus 1 over 6 x to the minus 2. So now it becomes 1 over 12x squared plus 1/3 x, and then minus plus 1 over 6 x to the minus 1 from 3 to 6. Plug in 6, we get 36 divided by 12 plus 6 over 3 plus 1 over 36 minus 9 over 12 minus 3 over 3, which is 1, and minus 6 times 3 is 18. 1 over 18. That's 3, that's 2, plus 1 over 36 stays, minus 9 and 12, that cancels by 3, we get 3/4. Minus 1 over 18. It's 4 plus, common denominator here is clearly 36. So that's 1 minus 9. No, minus 27, because it's 9 times 3. And minus 2. So we have 4 plus and negative 29, negative 28. Over 36, both cancel by 4. 7 over 9, so 36, 29 over 9. I hope. Unless you're requesting it. Is that a request? the next formula that is useful in some situations is if you want to switch the limits of integration. If you need to swap, let's say you get a problem where you have a smaller number as the upper limit, like 8 to 3, and you want to switch that into 3 to 8. How do we do that? What is the formula for it? The formula says that if you have the integral b to a of f of x dx, you can switch that integral a to b if you put the minus in front. Proof for this is very easy because remember that in the antiderivative you either have f of b minus f of a or f of a minus f of b. Well, if you try to commute the subtraction, you have to use the negative sign in front. So some of the problems in the textbook I noted, they have limits that are switched like this. So one of the homework examples says, just need to find it again. No need to break stuff. I'll find it. It is a very similar exercise to what we just did. This is problem 41C. It says go from 4 to 0 on 6x times 4 minus x dx. You will switch first, yep, using the formula. Possibly, I think so. Yeah, it is, I think. I had to put it online.
Would it just be like at the end of the chapter questions? Because they're all mushed together, right? So that would be like half of those. You just put chapter ones. But if they're wrong, you care way more about it.
It doesn't affect my game. The first order of business is to put the negative in front and swap the order, right? 0 to 4. And now one cool thing happens. You see this 4 minus x? This negative 1 in front of the integral can go inside and swap those. So that's really cool. So this -1, we know that we can kick constants in or out. So this 6 you can kick out of the integral, you can keep it in. Also the negative sign, which is actually -1, you can kick it inside. So -1 will distribute in the parenthesis and change 4 minus x into x minus 4. So now we have 6x squared minus 24x dx. And now we integrate 6x, that becomes 2x cubed, minus half of this is 12x, from 0 to 4. Plug in 4. That's what I said. Please pay attention. Thank you. So we have 2 times 4 cubed minus 12 times x 4 squared, and then zeros would just die. Now you can steal 1 4 from the 12, and as you can see, you have -64 as the answer right away. Because 2 minus 3 is -1 times 4 cubed.
You don't have to put the negative distribute the negative inside the other.
Yeah, you don't have to. You guys get -64?
Yeah.
All right.
I don't know what you said, but couldn't you just make the 6x negative?
Yeah.
In this situation,
And then
this situation or in other cases?
you can put, no, there's no other situation. It's all the same. You can make 6x, negative 6x. Distribute negative 6x, yes. There's just a lot of these, you know, cool little math rules that you can use to, you know, distinguish yourselves. That's a minus b is the same as negative b minus a. That's what I used. It's algebra rule. Yes?
So why and when would you split the a and b?
Because you will see in the last section 5.5 when we learn substitution, sometimes when you use u substitution, you end up with the limits being smaller number in the upper limit. Now, these integrals are set. Remember, the integral is calculating area under the curve. So when you are really trying to learn this, you say integral from a to b. Because when you have the area, area is from smaller letter a to larger value number b as you read left to right. And the representative rectangle dx would swipe all of those values from a to b, with a being a smaller number. So it's not just OCD that we have, but it is OCD that we have. So you count 3, 4, 5, 6, 7, right? So you want smaller number, you want to start from a smaller number, go to the higher. But then, as I said in 5.5, sometimes when we do substitution, substitution forces you to transform the limits, and the limits might end up having a smaller number in the upper limit, which would, oh, thank you. So that's why. Do you have to switch? Hell no. You can actually solve the whole problem 4 to 0, and then when you plug in, the upper limit is 0, so you will go f of 0 minus f of 4. You will still get -64. It's just, you know, it's OCD. Technically, yes. No, just u sub. That's it. Well, no, you can have substitution within substitution, but there are different types of substitutions. There are substitutions for triple integrals, double integrals. There is trigonometric substitution and all that stuff that you learn in Calc 2 and 3. But you can, in this class, you only learn one. It's called u sub, and then sometimes you have to do u sub few times within the same problem, which is okay. What's not okay is to have triple integral here. This is your Calc3. Change of variables is the U sub. So here's one problem. Here, starts here, 28. And then you do transformation of the region first, calculate Jacobian, and then you do the integral. And then you're done. So that one is a little bit spicier, as you can see.
So the one on the lab where it says use multiple substitutions.
You'll be fine with that, yes. That's Calc1. But we haven't learned that yet, so hold on. Do everything else. All right, so we did a whole bunch of these. You know, these all cute formulas that will help us. So there are also some other formulas that could help along the way. Formula a to a, f of x dx, is clearly 0. Because you will have f of a minus f of a. You are subtracting two values that are the same, right? So that one should be common sense. If your limits end up being the 0, that means that your area has a 0 width, right? So it has to be 0 area. And now, finally, we get to the last portion of this lecture, which is really testing our knowledge of graphing and areas and integrals and everything else. I would like you guys to try and compute the area under the curve for simple sine x dx from 0 to 2 pi. Go. So we are trying to compute the area under the curve. What happened?
Is above the curve count too?
What do you mean above the curve?
When it goes,
Oh, yeah, okay, yeah, sure, yes. You're getting 0, right? But we know that's a wrong answer. This calculation, by what you know so far, you are supposed to get a 0, which is a wrong answer. So there are some forces at work that we have to address. So if I draw the sine function, we see that half of the sine function is above and the other half is below x-axis. One brings the positive area, one brings the negative area, so when you add them up, because you know that integrals just add everything up on a pile, you actually end up with a net of 0, which is bad. You know that area is not 0 because you can color. You cannot color on a 0 area. That means no area. But if there is area, look, I can color. So now this means, because I can color, that area exists. So what I have to do is I have to be smart here and break this into two integrals. Break it into integral 0 to pi, and then from pi to 2 pi, where the negative integral I can put in absolute values, and then that would give me eventually a positive number. So this integral now is going to be integral 0 to pi sine x dx plus the absolute value integral pi to 2 pi of sine x dx. Yeah, we are giving ourselves double the work, but it can't be done the other way. Now you might see that it's symmetric, so you would say, can I just compute 1 and times 2? In this case, sure. But in some cases, when functions dip below x-axis, they're not going to be symmetric. So the positive and negative areas are not going to have the same value. You can't double in those cases, so you have to do the entire problem. So now what I do here is I have negative cosine computed, negative cosine x computed from 0 to pi plus another negative cosine x computed from pi to 2 pi, but the second one is in absolute value because I have to get the positive number to add to the first positive number. So now I have negative negative 1 minus another 1, and then I have the plus absolute value of negative cosine of 2 pi is 1 minus another 1, which gives me 2 plus 2, which is 4. And this is really awesome to have area under sine or cosine graphs to be 4, where you involve all the curves and pies and everything else. It's just amazing. So area under the sine and cosine graph from 0 to 2 pi is 4. From there you can just use common sense. What's the area from 0 to 3 pi? 6. 0 to 2 pi is 4, and then you have another pi to worry about, which is half of 4, so 2, so 4 plus 2 is 6. Good. So we have to be careful when the graph dips below x-axis and compute that part separately. But then you need to know the graphs. So that's why we have extensive graphing. Not just 4.3, but previous pre-Calculus 1, pre-Calculus 2 taught you all about graphing functions. So you need to know when the problem dips below and then deal with that part. So now I'm going to write here in blood that the value of the definite integral is not always equal to the area. That is something that you have to make sure you are careful about, because anytime the function dips below x-axis, anytime you have negative y's involved, that will bring the negative area, and stuff will start canceling. So all of those areas of the function that you have function go below x-axis, you must break off from the main integral and solve those separately in the absolute value. That concludes the first lecture. Now we're going to take a few minutes break, and then the second lecture is very, very short, and then we'll do the review again.